So what we're going to be going over today is how to display categorical variables. And I'm going to be focusing on two different data sets. One data set is just students that are currently in my class, and we're going to try to describe them and display that data. The other one is the passengers that were on the Titanic. And again, what we're going to do is describe what type of passengers were on the Titanic and try to display the data. The most frequently used types of ways to display categorical variables are frequency tables, bar charts, pie charts, and then we're going to spend a good deal of time talking about these contingency tables. So frequency tables, bar charts, they describe how much falls in each category. Whereas when we want to look at the category relative to the whole population, we're going to be looking at percentages, and that's in economics what we typically focus on. So the relative frequency, how much compared to the total population. Same thing with the bar chart, and the pie chart also does that. So let's say, for example, we go out and collect data, and this is the data on my students. So we have their name, what year in school they are, their major, their gender, and their class. And you can tell that each of these are categorical variables. And so we can count all of the female students up and all of the male students up. And we can count all the undergrad students up and all the graduate students up as well. So Econ 138 is an undergraduate course, Econ 435 is a graduate course. So once we've done that counting, we can figure out how many students fall in these categories. So for the undergraduate students, I have 22 male students and 11 female students, so 33 students in total. And this is what's called a frequency table. Now in economics, what we're concerned about is often the relative position of things. So we care about price in relation to other prices, or income of one country in relation to income of another country. And so we more frequently see relative frequency tables. And so for a relative frequency table, you calculate the percentage that each category is compared to the total. So for this, we're just taking the number of male students and dividing by the total number of students in that category. You times by 100 to get the percent. Same thing for the females. It's the number of females divided by the total number of students to get the percentage of females. We can display these two types of tables then in bar charts or relative bar charts. And the height of the bars then represent the count of each of the different categories of variables. So here what we see is the passengers on the Titanic. So they are classified by the type of ticket that they had. So there's about 350 first class passengers and maybe 300 second class passengers. And you can see most of the passengers on the Titanic were either third class or crew members. For the relative frequency, then, we're again just looking at the percentages or the relative proportion of the counts that fall in each category. Now, to display this with our data of students, we can take in Excel the counts that we had available. So this is the relative frequency table that we saw before. And we can simply make a bar chart by going to Insert, Bar Chart, and the simplest bar chart is just here. So we see that the heights again represents those counts. Now the relative frequency table isn't as accessible in Excel, but we can create something similar to that. So again, we can go to Insert, Bar Chart, and we'll go to this last 100% stacked column chart. And you can see these go now to 100. But if we right click and select data, we can switch how it treats the rows and the columns. And so now it's counting up the percentage of males in that column and the percentage of females in that column. So 67% are male and 33% are female. We can also create a pie chart in Excel by going to the Insert a Pie Chart, and again just hit the pie chart, and we'll want to convert this back to treating the rows and columns differently. And so here you can see that the females are 33% and the males are 67%. So a pie chart is going to show us how parts are represented in proportion to the whole. So each of these little pieces of the pie represent the proportion of which they are of the whole class that we're looking at. So again, about 3/4 of the passengers on the Titanic were third-class passengers and crew passengers. So we can see that easily in this because the last quarter is first and second class passengers. So the last type of table that we're interested in is called the contingency table. And the contingency table is really useful because it displays two types of categories in one table. So here with the passengers on the Titanic, we're focusing on the class of passenger as well as whether or not they survived the sinking of the ship. So for first class passengers that survived, 203 of them survived, whereas 122 did not survive. And there were 325 total. The total number of passengers on the Titanic is down here in the bottom corner. Now, when we do this for the students in econ that are in my classes, both the undergraduates and the graduate students, we add another column, and you can see I have 7 graduate students, 4 of which are male and 3 are female, and that last column then represents our total. So this is the marginal distribution based on gender, whereas on the bottom we have the marginal distribution based on whether or not they're an undergrad or a graduate student. So we can calculate the marginal distribution. Again, this is in terms of percentages because we're looking at the relative frequency of them in relationship to the total number of passengers. So the way that we can calculate this is taking each cell and dividing by the total number of passengers that shows up down here in the bottom. And we can do that for each cell then, and that gives us the cell distribution. So the number of first class passengers that survived the sinking was 9.2% of the total number of passengers. Whereas the columns on the right and the row on the bottom represent the marginal distributions. So the row on the right, the last column on the right here, is the marginal distribution for whether or not they survived. So 2/3 of the passengers did not survive, 1/3 of them did, so 32.3% of the passengers survived. Now, the way that we can calculate this, we can see through looking at the students that I have in my classes. Again, you're going to divide by the total number of students. So here in the very bottom corner is the total number of students that I have. That includes both graduate and undergraduate, male and female students. And this is the denominator in each of these cells. So again, we have the 4 cell distributions here, and these should sum up to 100, as well as our marginal distribution here on the column that falls in the last margin or the last column. So these should sum up to 100. So 65% of my students are male, 35% are female, and then 82.5% of my students are undergraduates, 17.5 are graduate students. So now that we have our table created, we can start answering questions that try to describe the types of students that we have. So here, this problem is asking us about the male students who are undergraduates. So what percent of students are male and undergraduates? And that is this cell here, the intersection of male students and undergraduate students. So the correct answer here is 55%. To answer another question that's similar, what percent of students are male but are graduate students? That's a different cell. So here we're going to be looking at the intersection of male students and the graduate students, and that's this cell here, which is 10%. So that 10% is the correct answer for this. Finally, if we want to know what percent of students are male, that would be the marginal distribution, and it's found in this last column here where we just look at the total number of males. So 65% of my students are male, and 65% is the correct answer. So now let's complicate things a little bit more and look at the conditional distribution. The conditional distribution means that you have some piece of information about the data that you're observing. So for example, with the passengers on the Titanic, if we're only interested in looking at the passengers that survived, we can remove the row of passengers that did not survive. And so we have some information, or we can have conditioned upon the information that knowing we're only looking at passengers that survived. And so the total that we're interested in is this total here of 711. So conditioned means you have some information, and that information is that the passenger survived. So we've removed all the passengers that did not survive. These percents then correspond to the number of first class passengers relative to the total number of passengers that survived. So again, we've conditioned upon the fact that they have survived. We can also condition upon whether or not the passenger has not survived. And so we saw that the number of passengers that did not survive was only 1,490. And so each of these percentages then correspond to the fact that we're looking at a smaller number for the passengers that did not survive. So the way that we can calculate this for the students in our data set is we can condition upon gender. So we're going to condition upon the fact that we're only going to look at the male students. And again, we had 26 male students, and of them, 22 were undergraduates and 4 were graduate students. So these percentages then correspond to the fact that we're only looking at male students. So now that we've created our table, we can answer some questions again about our student. But it's particularly important to pay attention to the wording in these problems, because that's going to give you a clue as to what type of distribution we're looking at. So here it says of the male students. So you have some information about the type of student you're looking at. So we can focus on only the male students in this problem. And then it asks what percent are taking Econ 138. So of the male students, there are 26 male students, and only 22 of them are undergraduates taking Econ 138. And so the correct answer is 84.6. We can also condition upon female students. So for the female students, there were 14 of them, and 11 were undergraduates, and 3 were graduate students. And so our distribution, our conditional distribution, looks slightly different than what it does for male students. We can also condition upon class. So here we're looking at just the graduate students. And since I only had 7 graduate students, the percentages again look slightly different. So 4 of my graduate students were male and 3 were female, and so we get different percentages there as well. So a wording for this type of question is going to look a little bit different, because now what we're focusing on is just the fact that the student is from Econ 435. So we're only focusing on those students and not the undergraduate students. What percent of those students are female? And so we're using the conditional table to create and find this percentage. The last thing to focus on in this video then is the relationship between conditioning and dependence. So here we have our 2 conditional distributions, one for graduate students and one for undergraduate students, and you can see that they look slightly different. This means that the 2 categories that we're looking at are dependent upon one another. So their class is dependent upon their gender. And what that means is, if we know if the student is an undergraduate student, that increases the likelihood that we would select a male student. Whereas if we know that the student is a graduate student, that decreases the likelihood that they are a male student. So what we see from these two different distributions is that the relationship between class and gender are dependent upon one another. So having information about one category changes the distribution of the other category. If these two distributions are exactly the same, we would say that they are, in fact, independent. The last thing I want to go over then is the importance of wording in the questions. So paying attention to the wording in the problem. If the word has in it an and, so here if we're looking at the percentage of students that are female and in Econ 138, that's a cell distribution that you find in that first contingency table. But if the problem looks at a subset of the population, so the percentage of females or the percentage of undergraduate students, then you're conditioning upon something because you're only looking at a subset of the population. You're not looking at all of the students. You're only looking at the female students. And so what goes in the denominator, what goes in the bottom of the equation, is just the total number of females. So that's it for this video. In the next video, I'll go over a few problems that deal with answering questions from a contingency table.